Hello, welcome to Math 70. This lecture video is on section 3.3, which is solving systems of equations by elimination. So this is another symbolic method. It will also always work for linear equations. But this is my real recommendation. We saw we had substitution as a method to solve it symbolically, and we have elimination. And my opinion is, why should we try to learn two when we could focus on getting really good at one method first? So I encourage you to focus more on substitution, to be honest, because that's more flexible. I am going to show you how to do it with elimination, and sometimes elimination makes it really easy, but substitution will also always work. So if you're worried about splitting your attention between two methods, just pick one, and I recommend you pick substitution. I'm not on the final exam, I won't ask you to use a specific method. I will allow you to choose what method you want. And if you have practiced substitution a lot, use substitution. If you practiced elimination a lot, use elimination. But let's look at solving systems of equations by elimination, just so you can see how it works. I'm going to use that same system of equations I've been using before, x plus y equals 5 and x minus y equals 3. So if this is true, then it should be true that if I add the left sides and I add the right sides, they should also be true, right? If I know x plus y equals 5, and I add x minus y, that should be like adding 3. And this is the whole idea behind elimination, is you can add your equations together, and sometimes you will eliminate a variable that way. Do not add them in line like this. I just wanted to demonstrate. What you do is you just add them vertically. So if I'm going to solve this with elimination, I would say I have x plus y equals 5 and x minus y equals 3. And I would just draw a line underneath and put a plus symbol. Put parentheses around there just in case. And what do you get? Well, you just add each of these vertically. So x plus x is 2x. Y plus a negative y is like y minus y, and that's 0. Those cancel out. And then on the right side, 5 plus 3 is 8. And all of a sudden, I have a simpler equation that's in just one variable. And I solve that equation, 2x equals 8, divide both sides by 2, and I get x equals 4. That's one of my solutions. And then I pick either of my original equations, like x plus y equals 5, and I know that x equals 4, so I go back through and I substitute for 4, and I end up with y equals 1 as my other solution. And if you've been following along in the videos, this is like the 6th time we found this coordinate pair as a solution. It's really as simple as adding one equation to the other. I'm going to give you another example, because sometimes you have to do a little bit of work before you can add your equations together. So what if I have 2x minus 3y equals 12 and x plus y equals 4? Well, I could add these equations together, but if I did, I'd have 3x and negative 2y, I wouldn't be eliminating a variable. So in order to eliminate, at least one of the variables must have the same coefficient. The coefficient is the number that multiplies. So the coefficient on 2x is 2. The coefficient on minus 3y is minus 3. And here the coefficient on x is 1, and the coefficient on y is 1. So instead of just adding, or maybe just subtracting, what I do is I multiply one of my equations by the number. Well, if I have a 2x here, then I want a 2 multiplied by my second equation. And that gives me 2x minus 3y equals 12 for my first equation, and 2x plus 2y equals 8 for my second equation. Now I can actually, I won't even add them together. Now I can subtract them, remembering that I'm subtracting everything. 2x minus 2x is 0x. That just cancels. Minus 3y minus 2y becomes negative 5y. And 12 minus 8 becomes 4. So now I have an equation in just one variable that's much easier to solve. Minus 5y equals 4. And I'll solve that by dividing both sides by minus 5. And I get y equals negative 4/5. There's one of my solutions. And finally, I go back to any of my other equations to find out my other variable. I can take my x plus y equals 4, and I know that y is negative 4/5, so I put that in. And I'm going to add 4/5 to both sides. And we get x equals 4 plus 4/5, which is 20 plus 4, 25ths plus 4/5, which is 24/5. And I'm kind of running out of room there, but this is good practice for you to follow through the arithmetic yourself. Okay, what were the steps? I looked at my equation and I said, for some reason, I'm not going to do substitution. Now, to be honest, I look at this and I'm like, I'm going to do substitution. About the only time I do elimination is when it comes in the form that's really easy to eliminate. But if you have a system of equations and you want to solve it using elimination, you make sure both of your equations have at least one coefficient in common. And then you can subtract one equation from the other, which will eliminate one of those variables, solve for the other variable, and use that information to solve for the last missing variable. And then you should check your answers. But I am totally out of room, and I'm running out of paper for the rest of the videos, so you can check those on your own time. And that's how we solve systems of equations using elimination.